Hello, hello. It is, yes, almost time. It is time. In fact, yes, welcome to the first, hopefully not the last stream. And our topic is ASP.NET, building a web API together. The idea, I have to set up something. Perfect. So, how does it work? The idea is I would just code and produce a lot of errors while you can write me questions, suggestions, things we go left and right. That is the whole idea of that stream. This is the first one. Probably it will go roughly 2 hours. Unfortunately, afterwards, I have to drop off. Therefore, I will continue this next week, presumably Thursday. I will let you know. So we have here the first comment, so I can show you how this works. I will just show you, for example, here, hello. And if there's a question or something I can showcase you, explain you, then just let me know. I will do that. I can also make it a bit bigger. Let me get this set up straight. Let's make this here. It's like that. That's my name. Let's try this hello again. Let's see how it looks. Yeah, that's bigger, I guess, so everyone can read it. To give you a taste, what we will do the next 2 hours or the next 4, 6, 8, I don't know how long it will take, to be honest. Let's see how far we go, is the following. Let me present my beautiful screen. Share screen. Let's go here. Let's take the entire screen. So I prepared a small Blazor web application. As you can see here, it's a very, very simple expense tracker. And the front end is basically given. And what we want to do is we want to fill in some life here. So how does that thing work? Well, it's very simple. Let's press on the add entry. Like expense name is a coffee. $2. Oh, $20. Yeah, it's Starbucks. It's a bit more expensive than usual. Category Starbucks. I press OK, and as you can see, I have an entry here. Let's add another one. Another coffee, which is this time really only $2. This is, I don't know, corner next door as a category. Doesn't make much sense, but you get the idea. Let's press. As you can see, we have a beautiful UI. We can delete entries. Up. We can edit entries. I can just like here too. Let's click OK. Let's delete this, and it's gone. If I refresh the page, obviously that stuff is still there. Another thing I want to show you is, let me duplicate my tab. As you can see, oops, I have now 2 tabs with the same content. And if I edit something, like coffee here, coffee, press accept, and you can see on the other side, my tab updates as well. If I would delete this here on my second tab, let's press delete. You see on the first one, it's also deleted. So the whole journey is about how can we build a REST API or web API. I will come to terms in a few seconds with you. What does that mean? What is REST? What is web API? We will also do things like SignalR. So we will enable real-time features, because what I did here, that I, for example, add an entry here, example has a value of 2, has no category, press OK. It automatically pops up here, as you can see, and this is just SignalR. So we will also discuss SignalR. Oh, hello. Here's small hi back. Oh, my camera is a bit laggy right now. I hope it's just my preview and you see me in a normal frames per second mode. I hope so. Is my at least that is fluent. That's fine. Okay, let me know how it is for you. So that's what we're gonna build. And obviously, we also need some kind of storage, because if I press reload, I obviously want that my data is still there. It doesn't make much sense if you just pass in something, the user presses reload, and all his data is gone. That doesn't make much sense. Therefore, we will also use storage. Here we will use Entity Framework with an SQLite database. So everything you will run, you can run locally. You don't need any setup. While I will go through the codes, guide you step by step, there is also, I will put this into the comment in a second. There's also a repository, basically this one. It's long, so let me copy paste that. Let's put this in. Let's send this to you. This is the repository I'm going to use. I will guide you quickly through the repository, what I'm doing with it, or how you can use this. There are a few setup things. You need some kind of .NET 8 SDK. You need some kind of a code editor. You can also use Notepad and the CLI, but yeah, probably no, don't do that. And you need a browser of your choice, because that thing here is WebAssembly Blazor, so you need something to showcase that. And the repository is structured in that way that you have a lot of branches. So you can see here's the main branch. The main branch is what I showed you here. It's the whole thing. It's SignalR, it's SQLite, it's Entity Framework, it's the REST API. But we will go through step by step. So you can start by step UI only. So UI only would mean you have absolutely no backend. You only have that Blazor application. And then you can go step by step through the branches, which builds incrementally the REST API. And I will do this over the course of the next streams. So basically, this repository is the base for everything. There's also a small explanation here what each of those steps are doing. For example, step 1 would be adding the project in the first place. So we need a backend, so we need a backend project, because UI only at the end doesn't have that project. And as you can see, step 2 is Entity Framework with SQLite, and then we implement more controllers, we do SignalR, we do logging, we do exception handling, and we even do testing. So that's the whole thing we're gonna do now. I'm not sure why my camera is laggy. Let me try something. If I do this, it doesn't get better, huh? This, whoop, 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 whoop. No, it doesn't get better. I'm really sorry for that. Anyhow, let's go. Let's code something. Time is valuable. We only have 2 hours, and I talked 10 minutes just about some stuff. Okay, let me go to my editor. So this is, by the way, the repository. I am on the main branch, as said earlier. Main branch is basically the whole thing done, so we don't want to use this right now. What we want to use is only the UI and then build incrementally. But maybe before we start, here a small thing how this whole thing works. I will just put this here into the comments so that you have a rough idea of what we're going to do. Here's my comments. Let's copy paste that. The whole application works like that we have a user, you and me, the one sitting in front of the monitor. Then we have the front end. In my case, that is the WebAssembly front end you saw earlier, the expense tracker. We have a ASP.NET Core backend. That is what we're going to build. And then we have some kind of storage, and we use SQLite with Entity Framework. And the general flow is pretty straightforward. For example, we enter an expense. That's, that user does that in the front end. That stuff, there's then HTTP post requests. What that is, we can also in a second. That thing gets saved, and we basically return, hey, that thing was successfully saved. And oftentimes you hear things like REST API, Web API, the thing I titled that whole thing. And what is the difference? So REST is a specific style, how to do HTTP requests. A Web API is nothing else than we have two parties, and those two parties via HTTP communicate with each other. That's all. That's just over the HTTP protocol. And oftentimes you have REST or RESTful, and this is an architecture style. And we come to that in a second. So the important thing here to remember is we want to enable communication between two parties. In our sense, this is you and the backend. You in the sense of you have a front end in front of you, and that front end communicates with the ASP.NET Core backend via HTTP. But it also could be machine-to-machine communication. There's absolutely no difference in terms of what you would do. It behaves roughly the same. There are obviously also other ways of communicating. We are using HTTP. This is also when you go with your browser somewhere, you do HTTP GET. But there's also stuff like SignalR, what we saw the effect of SignalR earlier. And you may also heard of something like gRPC, Google's Remote Procedure Calls. They are not based on REST, for example, they're not necessary. They are based on HTTP, but for example, they use a different protocol behind the scenes. So with that in mind, let's go to code. As you can see, I have here a backend project and I have a frontend project. That is nice, but it will go away just in 1 second. So if I go to UI only, as you can see, the backend is empty. There's nothing anymore inside. Gone. Because we want to build that thing. And for the time being, we also will ignore the front end. We will need the front end sooner or later, yes, but for now, let's really concentrate on the backend alone. And I want to show you two things, how you can get started with ASP.NET. Oh yeah, and there's a big thing that you should understand C#, I hope. I don't want to make a whole introduction to C# itself, so I hope you understand C#. Okay, let's go. Use this new project. Let's go. And here you have web. In Visual Studio, that might look a bit different. You can also use the command line tool, but at the end, they almost do the same. I want to use .NET 8. I also have included some preview versions, but I don't want to use this. Okay, and as you can see here, we have two things. We have a web API, this is what we want to build, and we have a web API native AOT. I will take the former one, and I will explain later what native AOT really means. You can see there's some authentication. So those templates from Microsoft, they get you started quickly. They allow you to bootstrap a lot of code without you doing anything. Oh, what did I say? gRPC is gRPC remote procedure call, not Google remote procedure call. Isn't G okay? Okay, I thought that G stands for Google because it comes from Google. It uses protobuf under the hood. But thank you. So we wanna use here the web API, and as you can see here in the advanced setting, there's by default something called use minimal APIs, and I want to show you both things. So .NET has basically two ways of defining backends for you. There's this minimal API, and there's a how do you call the other one? The classic controller. Let's start with the classic controller because a lot of documentation you find online will have these classic controllers. Let's call it classic controllers. It doesn't matter. I will delete this in a second anyway. Okay, let's create that thing. As you can see, we have a few files here. I will start with the program CS. So in the program CS is basically every backend you write is oversimplified, just a console application. So, and this console application spins up a server, and that server basically tells, hey, I'm on port XYZ. If you have requests there, I will happily answer them for you. And this is what a lot of Microsoft does for you. You don't have to do all the hard work you own. You just have to implement your logic. There's a lot of stuff going on here, and we will go through that step by step. First, there is here services to container. I will come to that a bit later, but whenever if you already worked with dependency injection, this is the dependency injection container. So the idea is instead of having all those new my service calls, you do the opposite. You basically say, hey, dear container, this is my instance, register that. And all the dependent objects are resolved by that container. We will see this a bit later, how this works, especially with DB context and entity framework, because everything we do, every service we have will live inside such a container. Okay, then we have Endpoint Explorer and Swagger, and this is a very, very cool tool for developers. I can show you in a few seconds if I press the launch button. Let's stop those two, by the way. And then we have some Swagger UI. Again, I will show you later. And those two guys with the app and app use HTTP redirect and use authorization, we will probably cover the next time. Why? Because these are so-called middlewares, and middlewares are something you can plug in your pipeline, but this is something we will do later. The interesting bit for the beginning is this stuff here, the services, because if you build your own services, you want to put them in that container. And the most important thing down here is these two map controllers and the run method. Map controllers, I can show you a controller in a second because I never defined what that thing is for you. Basically searches through your whole project and takes every controller and then, registers that thing, and it is usable. And app.run is basically like your static void main in a console application. So 99% of your execution time will be in that beautiful run method. Then let's go to such a classic controller. Let's go here to the weather forecast controller. A controller is, nothing else than, let's say, a group of actions which belong together. In this sense, we have a group of, weather forecast stuffs. We have here, for example, get me a weather forecast of 5 days, for a specific city. The city isn't even defined here, and return that. How does that work? First, let's go through. We have here a route. Route means this is the stuff we will enter in the URL of our browser, for example. So you need some way of a very unique name where you want to call that thing. Let me do something for you. Yeah, I know there's no multiple projects. How did I call it? I called it, as you can see, yeah, thank you. There's nothing. I want to start my project, which I called Classic Controllers. Let me do that. I want to show you something. The way that thing works is, we can also show you in Swagger now. It comes up on my second screen. Let me open that. Okay, let's go here. This is Swagger. Swagger is a tool which automatically lists all of your controllers and lists all of the objects your controller wants and your action wants. And the cool thing is we can try it out. What does it mean? Well, if we try something out, we really invoke our server. So let me just put a breakpoint here. F9, and let's press execute. Execute, loading, and you can see we are in here. Why are we in here? Well, as you can see, we have a name. So we gave that thing a name. We called it weather forecast. So if I would put in the URL also here with weather forecast, I would land in my controller. Then we have this get. Get means we want to get a resource. That's hopefully very, clear. It's very verbose. And what we are doing here is just, randomly just creating some entries. So if I continue here, then we are done. And as we can see, we get something back. What do we get back is a JSON object. So many of the UI frameworks or the default in modern web applications and their communication is JSON. So if you want to communicate between two services, oftentimes this is done purely by JSON objects. And we have 1, 2, 3, 4, 5 objects. That makes sense because we said we want to have 5. Okay, fair enough. With some, random data inside. There are also other protocols you can use, but I would start here with JSON. The cool thing is that, as you can see here, I never ever specified that I want to have a JSON or that, return JSON. And this is something ASP.NET Core does for us. So we didn't specify anything. So it assumes it's JSON because it's a nice default. So it returns JSON. You don't have to take care of that. Okay, I can, by the way, do the same. You can see the curl. Can see the commands here. I can do the same literally in my browser. So if I go to my browser, press enter here, I can see I hit my debug point, and let's go, continue. And I get the same object, well, with different temperatures, obviously, but I get the same structure back from my backend. And that's the whole deal. So we made sure we communicate from some front end, my browser or Swagger, with another party. That would be my backend. And my backend then processes data and returns that data back to the front end. And it doesn't matter which technology my front end is. As you can see here, this is some Swagger UI. I used here Blazor, and here I just used the browser. So we achieved a loose coupling between those two. There's no need of knowing that it's an ASP.NET Core backend. I just sent a request. I said like, hey, go to this address and make a GET request. And what do I get back? Well, the weather weather data for the next 5 days. Cool. That is in pure essence what a controller is. So this is a controller, and every controller consists out of multiple actions. And what I did here is basically telling, hey, I have a route, and the route is what I have as a name here. So this is my weather forecast controller. Therefore, if I would call that, let me rename this to something else. Let me stop everything. To, I don't know, dummy controller. Then obviously, let's go. And I execute that. What happens now is that my URL, let's open here Swagger again. As you can see, it's now dummy and not get weather forecast. A lot of information. I know. The important bits. Controllers have most of the times controller based an API controller in this classic style. What does that mean? These controller base give us some nice helper functions. So if I go to base, you can see I can temper, or I can inspect the request. I can inspect the response. I can do a lot of things. If you need this or not, we will see later. That is why we have this controller base. And also we have controller base because this map controllers, it needs some way of defining what is a controller and what isn't a controller. That's why we need this. The second thing is we have this API controller on top. And you can see also here, you will enable some features if you add this attribute. And this is now my segue into minimal APIs. So what's the difference to minimal APIs? Let's go. Let's create a new project. Let's call it minimal API. Minimal API backend or whatever. It doesn't matter how I call it. Let's go advanced settings, use minimal API. This is now very important that we use this. Let's go. Okay, now we have the minimal API. Just that you remember, we have this program CS. This program CS has here some stuffs, and it does this map controllers thing, which automatically looks through your assembly and finds in this term the dummy controller and registers that whole thing. This is how the classic one works. Now, how does minimal API work? Minimal API, if we go here, well, there's no controllers folder because they don't exist anymore. It's not like we have those. We still have controllers, but they are declared in a very declarative way. This is the same code as before. But as you can see, those controllers, well, they live now inside my program CS. And they don't live in a weird controller class, which has to extend from some base class. No, they just, they are just defined by a function. And that function is here. So as we can see, we have here this weather forecast controller. Let me start this. So from a using point of view, I call that minimal API. As you can see, I have a lot of projects here. Let's go. It always starts my wrong screen. This is still the get weather forecast call. So if I go try it out, execute, as you can see, I get my 5 items beginning from tomorrow until the 24th of July, 2024. Okay, easy. The difference now is we have way less code. This code is the same as before. If I go in here, that's the same code. You can see here, return enumerable range 1 to 5, and then, do some transformation. This is the same code here. But this one here around is way simpler. And the simplicity is something very, very, very nice, at least to me. If you want to begin with API controllers, I would suggest go down that route of using a minimal API because they are very easy, declared. You have your route here. This is something I can also type into my browser. So if I go back to my weather forecast here, I guess it's now a different port. It's port 7235. And to get weather forecast, if I would put it properly in, you would see, let me do that. Okay. Was it not? HTTP? Yeah, because I didn't use HTTPS. That's on me. Let's take the non-HTTPS one. And as you can see, we have the get weather forecast action dispatched. Cool. If I would change that here to dummy, obviously I can do that if I want to. If I change it, then let me get this here. Always starts on my second screen. Then you can see here is dummy again. If I would put dummy in here, then it works. Okay, let's go back to the browser. So with the minimal API, it's very convenient and very straightforward for you to create like a controller and an action. And you can do this, arbitrary often. I can make just another one, say map get, and let's call it hello world. And it returns just that string hello world. Okay, let's execute that. And let's put this up here. Oh, you see, I have a lot of open tabs. And then we have this hello world controller here. Isn't that beautiful? Let's execute that. And as you can see, we get hello world back. Okay, maybe we also see that this time, it's not an object. It's not a JSON object. It's just a string. So that's that. The cool thing is now you can start making funny things when we extend a bit the controller. Because what controllers allow you is to pass in data. I mean, it would be very helpful if all of your APIs don't have state or they cannot accept state from the user. Imagine you want to have some ID because you want to load something. How do you do that? Well, that's also pretty easy. You can make something like that, like a slash with like a directory. You could, from an abstract point of view, just imagine it like a directory where this is our topic, and then we get more specific. And I want to have some ID. And as you can see, my IDE already starts to say, hey, there's something special here, and I can call that ID. And now I can do the following. I can say, hey, I want to have an ID. And the minimal API understands that because of the same name, that, okay, whatever you pass in here is that thing. And now I can use that. For example, the user passed in, you see, GitHub Copilot helps me already. Let's re-execute that. And here, there's the magic of Swagger. Swagger understands what you're doing. So Swagger also understands that you have an ID here. And you can pass that ID in. It understands it's required. Why is it required? Well, let's go back to the code. That thing is an integer. It's not a nullable integer. It's just an integer. And if I put in a number here, like 100K and 100,000, press execute, then obviously I get this response back. The user passed in 100,000. I can do the same literally in the browser. So I can just go here, say hello world, hello-world, and put in 256, and then you get this back. Easy. Now we have a means of passing in data in one way. We will see there are many ways to achieve that. This is obviously one way. Let's go and discover some more. We may see here this map get, but there are also other things. And I want to explain what is there. For example, we have map post. Now we go into this realm of REST API. And in REST, there are so-called verbs, and the main four, I will just put them here. We do them one by one. We have a map put, post, and delete. Get, we already saw. Get is for the retrieval of elements. Oftentimes you have an identifier, like an ID or, GUIDs, whatever you're using to retrieve your objects. Then you have a post, and post is meant to upload data, create resources. Imagine the expense tracker we saw earlier. If you want to create an expense, you want to use something like post. Then there's also put. Put is, you can also use it for creating or updating. For the nitty-gritty details, we will discuss this later or in the next session. And I guess delete is pretty straightforward. Delete is deleting. So you want to delete an expense, for example. The important thing, let's start with post, is let's do something here. I want to show you two things. Let's say hello world. And I don't do anything here. I will not put in any data, and that returns just a string, test. So we create a post route, which returns test. Let's do that. Let's start this. Let's go to my Swagger. And as you can see, I have a post here. So Swagger shows you which verb you're taking. And those verbs are basically important in the sense of that a consuming party, like me right now in front of the screen, knows what to expect from your API. If I see a get, I would assume, hey, if I call that thing, I can get data back. And it doesn't matter how often I call that thing, it will always give me the same data. Well, as long as no one deletes the data, you get the idea. As long as I'm the only user, the state stays the same. So get will not mutate any state, and I can call it like thousands of times. Post is obviously different because, as I explained, if you want to create something, you mutate the state, probably of your database. And I want to try it out here. There is no parameter, so I can just call execute. And I call execute, and you can see here, there's test coming back. Okay, cool. Now let's do the exact same thing, but I do it in my browser. I just go here and press hello world. And as you can see, I get an error. It doesn't work. I can also go to the network tab. Let me just make this a bit bigger. Can I make also this bigger? Oh, I cannot make this bigger, huh? Let's reload. And as you can see, I have an issue here. There's an error. And we get this 405. What does it mean? We get the 405. Method not allowed. The way a server communicates with the other party in a web API is mainly also by status codes. So if I get a request and I want to indicate to the other party something went wrong or something was good or something, horribly went bad, then I send them back a status code. You notice that oftentimes, if you just go to a random URL like this and press .com, then you get a 404. 404 is a status code for not found. And there are really many of them for a lot of scenarios. In this case, method not allowed means that my browser does only do GET requests. So if you type in an URL in your browser, what your browser does always is doing HTTP GET requests. So you're doing some kind of a web API to the other party, and you're doing GET requests. But on this specific route, I only allowed post. Let's go back to the code. As you can see here, hello world itself, not with any ID, only allows a post. So what should the server now do? Well, it tells me that there is something. It's not like, on this route, if I type in, for example, here, hello world 2, then obviously here, if I go down there, it tells me not found. There's nothing behind that route. But here, it tells me there is something behind that route, but that thing is a different method. And the methods is the verbs I meant earlier. Post, for example. And this is where Swagger becomes very, very handy. It's super handy because, as you can see here, it's successful because it does that post request for me. It's like Postman. So if you ever use Postman or something else, it's basically like that, just in your UI, automatically retrieving your stuff in your project. That's the cool thing. Cool. Okay. Now, why is this important? Let's do some trickery. Let's, remove this part here. Let's remove this map get. I'm not interested into that. But let's do the following. Let's say here post. Let's say here get. Sorry. Let's do the obvious candidate. Let's do a app map put hello world. Exactly. And let's do the same with a delete. Hello world with quotes is a valid. Yeah, that's true. That's true. I guess, yeah, that's true. So atomic values are valid, Jason. That's true. Yeah, fair, very fair point. So now my question to you, before I start anything, will this lead to any trouble? So, for example, if I go with my browser to Hello World, or I do a post request to Hello World, what is your expectation? What will happen? Let's see. Let's execute that code. Okay, we have, like always, our Swagger. And let's just take the URL and let's go to hello world without anything this time. And as you can see, we get back. Okay, cool. That's what we wrote here. This is literally that line. And as you can see here, I can go to post and let's execute post. Oh, yeah, try it out. So the important thing for you to remember is the URL itself, this identifier you put in here, it alone doesn't have to be unique. What has to be unique is a URL and the HTTP verb behind that thing. In this case, it would be post and hello world. And obviously here we have get, put, and delete. And this is normally how you would define your APIs. So oftentimes you have stuff like that where you say, hey, if you want to create a resource, you go, for example, to hello world and, we create that thing. If you want to make a get request, you would argue, hey, oh, I pressed on my Git branch. I'm sorry. You would create now here, hello world. And then you have the ID. You can even say what this is, by the way. That's the cool thing. That's an integer. Int ID. If you want to delete this, you would also do the same. So from outside, you know exactly hello world. You have an hello world object, and you see all the possible mutations. You can obviously also do something like that, but that's not very common to see. So the most common thing is, if you do especially public APIs, is really to have the same identifier, and then you have map get, which gets this, and put. You would probably do the same here. You have also the ID, because you could probably say like, hey, this is updating my object. Okay, we discussed very, 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 very briefly what post, get, put, and delete is. Cool, but we are far from creating our expense tracker. Our expense tracker wouldn't work right now. And I want to make that thing work. So let's go. Let's remove all the clutter. I don't want to have this. I want to start from scratch. I want to say, hey, I have my routes and my routes only. For that, I want to do something. I want to go with the terminal and just start my front-end project. I want to start that thing here. And I always want to keep it, in .NET CD frontend. You can also do this with the library, with the GitHub repository I provided. So no, not in spin, .NET run. So what we're doing right now is I will only run my front end, and that's all. So here's my front end. Let's put it here. As you can see, it doesn't do anything. It even has an error. So if I go back, it will just do nothing. And why? Well, as you can see, it tries to go to a specific route. Here, local host 7001, API expenses. The problem is nothing is running there. Okay, so what we have to make now in the next, let's say, hour is to make sure that our server is basically running there and exposes those endpoints so that my front end can retrieve some data. Okay. I don't need you anymore. I don't need you. I have a lot of browsers open. I like that. I already prepared something. Let's do here a very, very, very short domain object, because we need some object we want to send back and forth. So here is my expense. That's the basic class we are using. So there we go. It's just a simple record. It has a name, it has a value, it has a list of categories. So everything I typed in earlier just defined as a C# object. It also has an ID. We need this later. The ID is important because databases are operating on IDs. So we need a way of saying, hey, this is the unique identifier for that object. And this is what we pass around if a user is asking for a specific expense or for all expenses. It doesn't matter. Okay, so we also have here an update method. It's basically used later. So if I want to update an expense from another expense, I just, overwrite those values. Okay, that's pretty straightforward, I guess. Let's go and implement our controller. We saw earlier that's pretty straightforward. Let's go here to the program CS, go back here. And the first thing I want to do is I want to have the get request working. So what we're doing here is a map get, because I want to have the get request. And I want to say under API expenses, I want to get a list of all the expenses in my system. Just let me double check if yeah, here you can see expenses. What this part is here, I will showcase you later. So we have expenses. This is the interesting part. And when we call that thing, let's return an empty list. For now, let's just say we have an empty list of expenses. Expense, didn't I? I put the expense in the, that was the wrong project. I don't need this here. I need this obviously in my backend. So that's also maybe something which is very cool, that even though I have an expense representation in my backend and I for sure have one in my front end, they don't have to know each other. It's pure coincidence that my backend and my frontend both are C#, but they can be whatever they want. Okay, so now I have an empty expense array. Then let me just do one thing. I said earlier, I want to run that thing on port 7011. And I can tell basically.NET, please always use that port. Now, in a real world application, you probably will do this a bit differently. You have app settings and other means. But for now, especially in the beginning, we will hard code this value. So if I run that thing, now let's go. Then the builder succeeded. And let's go to my expense tracker. Where's my expense tracker? Here, expense. I will start again. And we can see there is still an error. And there's a long error message. And if we look in the network tab, we get something here. And this is written like 200 OK. So there's something really wrong. What is wrong here? If we close this here, I want to put the emphasis on this little word, CORS. CORS stands for Cross-Origin Resource Sharing. And as a developer, you most likely hate it because it always comes up and you are always thinking, okay, why do I need this? So what is CORS? What is Cross-Origin Resource Sharing? Resources is what you retrieve here. So when you do a get, that thing behind that list of expense, that's a resource. You're always sending resources back and forth to some extent or another. And what your front-end or the backend is complaining here is that the origin, that's that thing here, that's localhost 5180, is different than the one from the server. The server has this port 7011 and the frontend has 5180. From your browser's point of view, these are two completely different things. It's just mere coincidence that they're running on the same machine and same box. But from your browser's point of view, they could be also one in America and one in India. It doesn't matter. Your browser's complaining here because he thinks, hey, these are two different things. It's risky to do what you're doing. And your backend is then telling, hey, I don't want to receive a request where I have absolutely no idea where this is coming from. Now, why does your backend in the browser do that? Well, imagine someone is injecting some scripts in your website. You obviously don't want that they are just executed. Just imagine you have a bank account. There's some malicious JavaScript somehow implemented into your browser or by whomever. And this code snippet, which is not in the context of your application, shouldn't be allowed to execute code. It shouldn't be allowed to make HTTP requests. So the thing is, you have to tell your backend which frontend it wants to allow to make requests, or which address with which resources, which origins it wants to share information. And this is where this whole thingy here comes in. So we have here these services course. Sounds very familiar, like earlier. And add course basically adds something that allows ASP.NET to handle those course things. And here you can just, do an action. So here's the configuration, and we do this for now. Let's see what, no, that is not great. We have these options here, and we can say, I want to have here the policies. I can say a default policy. I can give it names if I want. For now, I say a default policy. So whatever I do, always use this course policy. And then there's another lambda. So as you can see, there's a lot of stuff you can configure. I want to say allow any header. So it doesn't matter if it's a post, get, put, or delete request. It's always fine to me. I want to say allow credentials. It's not so important right now because we are unauthenticated, but that might come in handy later. And we want to say, hey, with some origins, we know for sure I want to share resources. And in this case, the resource I want to share, or the origin I want to share, is my frontend. So this guy here, localhost 5180. Let's put this in. Let's give it a shot. Let's give it a shot here. So now the only thing we have to do here is to say, hey, use course. Now that seems redundant, doesn't it? We have something up here and we have something up here. The way it oftentimes works in ASP.NET is that before your app builder.build, this is a lot of configuration for the service container. And stuff here is stuff you're really, really using from the get-go. So when you start this application, this should be available. From the moment you press the .NET run or whatever you do, it should be available. Let me restart my application. As you can see, it's up and running. And now let's do Control R. Oh, that was a bit too early. Now I still have an error. And the error, that is my own fault, I can show you in a second. If you go to the network tab, oh, we're still at course error. Yes. You see, that's why I said earlier, you will see me struggling live on stream because now the origin, you can even see it here. I am. So app run, the origin is in here. Did I copy paste it wrong? No. Okay. Then I have used course. Let me think what I did wrong for a second. I do think default policy should be with origins, any header, credentials. That looks very nice. The only thing I'm thinking of which is wrong is let me do something. Let me do something. You can also use named policies. So I can say here test. I know that's a great name, test. And I can say down here, test. That's the other way of doing it. You can just give specific names. The advantage of this approach is you can basically have a very, very fine-grained system where to certain actions and certain things you want to use that policy, and sometimes you don't want to use that policy. Let's go. Let's do it again. Let's refresh. And I still have a course error, so that's not the problem. That is very interesting. So what did I do wrong? Here we see some browser stuff. It is the HTTP client, which doesn't want to work for me right now. And it is a course error. You can see this, by the way, also here. You just joined in. We're just building some ASP.NET Core 8 web application with some Signal R and stuff like that. Yeah, that's the tech stack is C#.NET. Some databases with SQLite later on. Let me hide this away. Okay, and I'm struggling with cores as any method? I forgot that. You see, I was wrong. The headers, obviously HTTP headers, like the status code, which is sent back from the server to the client. But method is something like get, post. So there we go. I told you, I will struggle. And yeah, that looks not better. I'm still not sure why I do get the course error. Has blocked by the course policy. You know what? There's always this method where I say, now it's the, there's always this where you can say allow set is allowed origin. So this is like the most unsecure thing you can do. I basically tell it doesn't matter from where I'm coming. I always allow the course request. Well, that's how it is. That's life. As you can see, we get something back. Hooray! The course error is gone. Interesting. But that's not what I wanted to show. What I wanted to show is we have this new list, and I want to, fill in some life. So I want to create a new expense. Say like name is chocolate. It has a value of 10, and it has some categories like tag 1 and tag 2. And what else do I want? I want to have a date only, which today is 2024, 7/19. Okay, so if I do this, let's do this again. So exactly, it's not secure right now. The problem is I basically allowed every request, every course request to go through, and that is not a great idea. So, but if I just refresh here, you can see the stuff I hard-coded in the back end is working. So this thing here is just not good. The issue is that now it doesn't matter if there is some script running from a third-party host, it would still be allowed to make those requests. And obviously, this is not what you want. What you normally want is to say with origins, and I'm not sure why it doesn't work. HTTP, not 7, this one here. This request should be allowed. Only this should be allowed. If I do this again, let's try it again. I want to know what I screwed. Let's do it again. Yeah, exactly. And it tells me it has been blocked. No, the origin is present. I hope you can see it. And I'm not sure why it doesn't want my course setting. Because this is literally the address I gave. But maybe it's not good to have the slash in there. Because that's not true. Oh, yes. You see why I don't like course? So the issue was the whole time that the origin should be basically this trailing slash. You have to remove that trailing slash. And I didn't. I just didn't. And therefore, it complained. So with this setting, I basically allow HTTP localhost 5180 that it has access to the backend. Oh boy. You see, I do web APIs over 10 years, and it screws me every time. And the thing is, if you do something like Azure or AWS, where you configure this also in the portal, and then you just deploy, and 10 minutes later, you come back and you get these weird course errors. You're just like, but guys, don't do just don't drop that. It's a good security feature. It shouldn't be the only security feature you have in your application, but it's one of many which makes it harder for attackers, to get your stuff. So please use it. It's there for a reason. Okay. That said, we found a way to already, retrieve items. So if I do another one here, chocolate 2 and 20, and just, recompile that, go back to my application. hit the refresh button, you can see there are 2 now. And it always starts Swagger. And that's cool. But obviously, that's not the end of the line. Mainly because A, my stuff is hard coded, and B, if I press delete, then, well, there's an error because there's no delete. We never defined the endpoint for delete. So we have to do this now to some way or another. We start now easy. Let's say we have everywhere our methods we have to define. This is also API expenses. Expenses, exactly. And as you can see here, this is a bit different. A post request allows you to have something like a complex object. I mean, we can see here, that's a complex object. This is not just a string. It's not just an atomic value. That's a whole complex thing. So how does it work? Where do we put this information? Let's try that out. I want to show you. Okay, let's go back. Let's use Swagger again, if it starts at one time. Dear Swagger, do you want to work now or not? Here, exactly. It's on my second screen as always, so you don't see it. Very, very secret. Here's an expense. And the cool thing is you can see here request body. So if you have complex object, and that is the big difference to a get, you can push data in the body of a request. And we can see this easily. Let's go here to the network tab. How does that look like? If we go here, try it out. ID, one, it doesn't matter. Name is Steven, value is 20, some category. Right, we have 2024. Here's 7, and the day of week, it doesn't matter. 2, and also 2. Doesn't matter. What happens now if I press execute, we can see here, we get first an error. That's because of a different reason. But if we go here to the payload, you can see this data you put in here is part of that request. So if you do post or put a request, so exactly. No, the question is absolutely legitimate. There are 2 ways. So if you say controller class, at the beginning, I showed 2 ways of defining controllers in C#. Let's go back here. I use the classic controller approach. That's what a lot of folks know, where basically you have this controller, which derives from your controller base. You have some attributes and whatnot, and then you do your magic inside the method. That is, how a lot of documentation is done in C#. But since C# or since .NET 6, there's also this way of doing it with the minimal API. And this is this part here. And this is more expressive. So if I scroll down a bit, or not only more expressive, but as the name suggests, it's minimal in the sense of minimal setup. And it's especially for beginners and other frameworks like Node and Python, they do similar things. It's a way easier entrance. The barrier of writing controllers and actions is way lower than with all this fuss you have to do with the classic controller. My question to you, Spiritual Mind, is this what you meant with controller class? I hope that's what you meant. I assume that's what you meant. So here's the cool thing is you can just, as you can see here, you get the body in as an argument in your Lambda, and you can just use it. Super easy. You don't have to do anything. With one line of code, you can make a lot of things happen. And that's why, especially for new beginners, for me, it's out of my opinion, the easier approach to go to. There are some things I will discuss later where minimal API falls short. And the classic approach is better. And oftentimes in enterprise applications, so if you have lots of APIs, we're talking lots of APIs, especially with the versioning, the other approach might be more suitable. Absolutely. But for this entrance, especially if you want to build your own API, I would go ahead and take the minimal version. Okay, back to the browser. What we did here is you always have, if we go back here, if you do requests, there's always a header part. Header are just metadata about the stuff you're doing. You can see where should it go, the method, where did it come from, and blah, blah, blah. A lot of information, a lot of information. You can scroll down here. You can even see, hey, the user agent. So it came from a Chrome in that version. Fair enough. And then the other side, so the backend in this case, makes a response. This time it has a response and has a problem with something. That's fair. And it is probably with this, because this is not valid. It's probably, if I can just remove that and it works. It is 24, day of week, let's say that's 0. Let's go ahead. That's also wrong. I do not know which the 2nd of July was. Anyway, the interesting part is that you put this body, or the browser does that for you, or your favorite front-end library does that for you, puts such information in the body. So you can put complex object almost as large as you want. Almost. There is a caveat to that. Inside that body, and then your server on the other side receives that. And as you can see here in the minimal API, that's the wrong one. Here. And as you can see, it automatically tries to deserialize that object into that representation. In this case, it fails because it's not valid. The problem is that if I have here day of week, it was the wrong value, but that's fine. That's fine. For example, day of week 10 doesn't make sense. So this is an enum. If we go into here, date only consists basically out of a few properties like day of week, which should be, divided, should be a value between 0 and 6. So if I put a value of 10 in there, that doesn't make any sense. Okay. Let's go back here. That's not what I wanted to show. What I wanted to show is I just wanted to create all the API endpoints and then fill it with live. So then we have also map put. This is now our update case, if you want to say so. So we have an ID. This is, the thing we created earlier. So this one, we return this whole object to the browser. So do we need to add any middleware to automatically map a request payload with the model? No, that's the beautiful thing. You don't have to do that. You only have to do specific things if you want to say, hey, my model is, or the payload. So this here, or let's say this one, always assumes you have JSON. That's the default. I mean, many web APIs and REST APIs are working like that. But if you want to do something else like XML, then you have to tell the API, hey, I want to have an XML as a return value. Or if you want to have it as a plain string, you could also do that. Whatever you want. And that's then up to you. But the default, if you don't express other intents, is always JSON. I hope that answers your question. Okay, perfect. And that's cool. That's, very reasonable. Maybe in the future, if we have time, if we find some interest, we can just build the same application with different API styles. So we could do it once with GraphQL, we could do it once with gRPC, we could do it once with just plain WebSockets. Why not? Doesn't make much sense, but we could do it. Why not? Just to get the hang of how different API styles feel. How would you, do it differently in your code? So we have post. This is basically my update case. I just write it in as the update case. This is the, Copilot, you're so smart. Retrieve all expenses case. And then obviously we also have, that's not plural because we only want to have one. We also only add one here. And we have the delete case. And delete, yeah, exactly, is we do delete also with the ID. So if the user, sends a request with the ID 5 and there is something with the ID 5, then we just delete it. That's that. So if we start this, let's do it again. We will have, and I see my Swagger. Let's refresh that. So these are our 4 endpoints we will need throughout, the whole session, basically. That's all. This will be live. I guess it's recorded to YouTube and it should be afterwards directly live available. Maybe also for you, you can go to here, this one, Net 8 Web API Workshop. Basically, it consists what I'm doing as a repository. It's structured in the following way that, yes, you have some, you need .NET 8, you need an editor. And every step I do is basically reflected as a branch. So you start from UI only. This is basically where we are right now. So if I look into, okay, let's go to the console. Let's open one. You can see here, you cannot see it because the thingy is over and my face was over it. So you can see UI only here, where my mouse is, UI only. And this is where we are right now. And then each thing I do right now, like you see here, course, creating the first requests, I did as a branch. So you just say git switch to step 2 or to step 3. And then you can decide whether or not, you want to implement this on your own. Or if you're stuck, you just check out the branch and, check what I did. Obviously, there are multiple ways to the same goal. So just the way I did it doesn't mean it's the only way or the right way. So there are multiple ways of achieving the same goal, just that you know. But that thing is just publicly available. I can just put it again into the chat if you want. You can just, clone that thing and do whatever you want. Good. Hello, expense tracker. Exactly. Okay. You might have noticed one little thing here. We have a fairly simple application, which is nice, but already this file gets bigger and bigger. We have here like 15 lines of code, and I didn't do much. It's just hard-coded data. I just returned something. So I don't do much at all. So the first thing I want to do right now is I want to organize that. And I want to organize it in a way which is extensible and the way I like it. So how can we do this? Let's start and let's use a folder named controller. And this one seems much like here. We can also use pluralization. Let's call it controllers. Why not? How does it work? How can we nicely organize that? The way I like it, especially in smaller projects, is via static extension methods. Okay, let's do this. Assume this is everything we have here is called expenses or somehow expense related. We could have multiple things we do. We can have expenses, we have calendars, we have users, whatnot. They can have their own controller. But for now, I want to have an expense controller. And this is roughly what we, called that thing earlier in the other project style. And the way I like to do it is this one. Let's go. Let's say I have this expense controller, and here now I want to say map expense controller, and I want to have this. And now what I want to do is basically the same way as here. I want to build on top of something where I can just say, hey, let's do it up here, app map expense controllers or controller. This is the way I like to organize my things. So that it's painfully obvious if, for example, here, user controller, that I have multiple concerns in my application. Map, settings controller, whatever you have, obviously, we'll only implement the first one, but I hope you get the idea. I want to have a mechanism to showcase, hey, this is my somewhat construct of an expense, and these are all the endpoints important for that thing. And we can achieve this easily with endpoint builder or root builder. That's app. And now we can just move this stuff, you can see here already my ID is telling me, hey, there's something, just use the import. Oh, and it's working. And what I can do now is basically I just take all that code until here and put it in here. Well, the comments are not working, the indentation, but the rest is working as it should. And now, you can have multiple controllers. You can have, you can have multiple functions here, and it's somewhat nicely structured. Especially for smaller to medium-sized projects, that is a very nice way of achieving that. So, if you just look at your app or your program CS, there's not much gonna happen. And if you're really interested in the details, what's going on, you just go in that controller and check out, what you want to check out. Let's start this again just to showcase you that it's still working the way it should work. Where is my browser? It is here, I guess. Expense. No, that's the wrong one. I closed that. That was not smart. Steven. It's 7011. Yeah, exactly. So we see there is still get, post, put, and delete. How can we inject services? That's a very good question. Let's do that. Before we do any, let's remove this. Before we go into the detail of like SQL and HTTP framework, let's create a sample service. Okay, I will just do it here. Let's call that sample service. And that sample service, it doesn't do much. It just returns a GUID. Why not, get GUID? And basically what it does every time, just creating a GUID and just return that to the user. Okay. The thing I told earlier already is you have these things here. That is your service container. So this is the stuff where all of your services will live, or the majority of your services will live. And we can just say, hey, I want to add my sample service in here. So what we are doing here is to tell the Microsoft dependency injection thingy, hey, put in your sample service. And now if I retrieve sample service, do that for me. The cool thing would be if you have dependencies like this, for example. If you want to have a dependency, logging, remember, just call it logger. That's absolutely fine. Let's log something just for the sake of logging. Log debug. Let's see what. Okay, that's fair. In a normal way, if you don't use a dependency injection container, how would it look? Well, let's go into our service. Sorry, I'm confused. Let's make it here because it's not related at all to our expense controller. So let's go here and say like app map get. I want to have a GUID. And now, how would it look in a classical way? Well, you would say I have my service and you just new up that service, sample service. But now you have to, know all the dependencies and you have to resolve the dependencies on your own. That is not what you normally want, especially just imagine this would change. It's not iLogger or you have a new dependency. That's shit. Because why? Yeah, well, because you have a lot of broken code and you have to go through every of those occurrences, even though, you didn't change anything in sample service itself. And the way it works with dependency injection, or broader term is inversion of control, is that you have this container and this container thing, this friend here, he should figure out for you how to resolve those dependencies. And how does he do that? Well, you put in all the services you have, and then basically it creates a tree of dependencies, and then it knows exactly, sample service needs locker implementation. I have that locker implementation available, and puts it into your service. How does it work with the minimal API? It works the same way as almost everything. Your lambda is basically your way of retrieving things. It's your way of retrieving this stuff here, what I showed earlier. If I have an ID, I can make int ID. We saw earlier in a post request, we can get the body via this lambda thingy here. And what we also can do, let's just remove this here for a second. We can also get services that are in the service container. We can retrieve them easily also in this lambda. So if I take my sample service and just basically say return, no, we want to have this one. Yeah, exactly. Something, oh, that was good. Yeah, something like that. Then we are utilizing the service completely from the dependency injection container. There's no need for me to create that thing. There's no need to know exactly how to resolve those dependencies. The container should take care of that. And we can do that quickly. I have here one of my Swagger UIs, of my many Swagger UIs. That's GUID. And let's try it out. I just execute. You can see here there is GUID. So this is this term. We get a random GUID. Yeah, and that's basically all. We have the web app here. This is finished. So this is the way how you would inject services. That's all. Put all of them in your Lambda. So all of those requests always look the same. If you just look here on map get, you can see it on the right side. You have this pattern here. That's the URL. And on the right side, you have a delegate. And that request delegate is basically, you can put in whatever you want. Again, objects, services, even this request object that could ask HTTP request object. I could ask for a lot of things here if I need that. While we are, sure, let's stick to it for a second. For folks that might be new to dependency injection container or only worked very, very briefly with it, you can see here an add scoped sample service. Oh, that's easy. Let's do something. You can see here the GUID is 560029DDDD, blah, blah, blah. Oh, wait, sorry, there's still overlaid. That's on me. So we still have the 560029DDDD, blah, blah, blah. And I want to try something. What happens here? No, that does work. That was on me. Sorry. Or this. Yeah, there you see it better. What does scope mean? And what else do we have? Let me execute that thing a few times. So execute. You can see it changed. Execute. It changed. Execute. It changed. Okay. Let me change that for a second. Keep in mind, it changed all the time. As you can see, there's scoped, there's singleton, and there's also a third one, and that is transient. At transient, I don't see it. Because I started already with the S. I'm sorry, there's also a transient. Let's go with singleton. What changes if I use singleton? Let's go. Again, the service here, I never touched. The only thing I did until now is from scoped to singleton. Okay, execute. There's a new ID. Execute, execute, execute. And it changes also all the time. What did I? Is it singleton? Did I build new? Wait. This is not. I have to build. Sorry, I have to build new. That was the wrong. That's interesting. It shouldn't do new IDs, and you will see in a second why. That was on me. Localhost 7011. Try it out. Am I stupid? I have my GUID. Oh, that's my GUID. Wait, now I'm confused. So, yeah, exactly. I'm also checking exactly. So singleton, maybe that's a good thing. We have 3 lifetime scopes. As you can see, I'm always making requests. Scoped means it's stable over one request. I show you later in some more detail a bit better what this means, but I'm just interested. Let me go to my program CS. So I defined that thing as a singleton sample service. So what it should do is there should be only one instance around, kind of like a cached instance. You can just imagine it's like a cached instance. Because I'm stupid. Sorry. I am so stupid. Because obviously, while the instance is oh god, I have to remove this. While the instance obviously is a singleton, that call is stateless. But what we can do to make that painfully obvious is, let's do it like that. Sorry, exactly. Let's use, once that object is created, we store that GUID and we return it here. Now you will see the difference. And you know what? We will do this twice. So we will do a sample service 2. Why not? Because we can do that. And we do the same here again. GUID 2, and we use sample service 2. Let's execute that. That's a way better example. So here's my Swagger UI. Can you please, I have to fix that it uses the right port. Okay, perfect. Let's go in. We have the GUID. Let's execute that. Remember, we have singleton. So you can see these two are the same, always. I press execute. I hope you hear that. And it stays same all the time. So singleton means from the beginning of your application, which would be basically line 4, until after line 42, you will always have the same instance. And that is cool if you need kind of like a global thing, or you have very expensive resources you don't want to create every time. Okay, let's switch this up. Let's come back to add transient, because I didn't show you that. With add transient, every time you are requesting a service, every time, and just that keep in mind, these are 2 requests to that, you will get a new instance. So you can see here, these are two different UUIDs or GUIDs. So every time I click, you will get completely different GUIDs for every request that is retrieved from the container. So the obvious thing in the middle is add scoped. Add scoped means for a request. So, once I press that button until the answer comes back from the backend, that thing is always the same instance. So it's kind of the middle ground between a singleton and transient. You could argue it's singleton inside one request. So let's execute this again. Then this beautiful wrong overlay will come again. Content path. Close that. Where is my browser? My browser is here. And if I execute here, you can see those are absolutely the same. Every time I make a new request, they change. It's kind of like the transient thing, but it's singleton for every retrieval of the service inside that request. Well, is this important? Yes and no. When should you use something? So transient, obviously, if you are very stateless and the creation of that service is super cheap, go for transient. Barely you will use it. Scoped is the default you probably use for every service. So every time a request comes in and you ask for that service, that instance will be created. This is especially important if you think of a request like it's an atomic operation. So every time your user clicks, for example, save or load, that's kind of one thing. It's one operation, or it should reflect one operation. That doesn't necessarily mean one operation is, for example, only one operation in the database. And that's the important thing. If you would say, hey, I have a database and the user presses save, and he has expenses, he has some user settings, and they are all a bit bundled together, then you want to make sure that those services and the database at the end is in a consistent state. So either everything is saved or nothing is saved. And so it makes sense to model this in a request lifecycle. And this is exactly what Scoped is for. We will do this later with DB context and EF core, which I guess I will go to now. If there are no other questions, I guess I will go to Entity Framework. We will see how Entity Framework works. because right now, well, yeah, there's no state really. The only thing I did is hard coded stuff. Cool, but yeah, it doesn't do much. So let's create a database. And this is, yeah, relatively straightforward. Let's go. We will add here the package. So how this works in .NET in general is you just add NuGet packages. And that would be Microsoft Entity Framework Core. Entity Framework Core. And what I want to do right now is I want to use an SQLite database. The cool thing, and you have to write it correctly, by the way, otherwise it doesn't work. Why do I like to use SQLite? Well, SQLite is serverless, so you don't have to have a specific service running in the background, like a SQL server, RavenDB, MongoDB, you name it. And it's perfect for local development. And for very small, or for even for smaller to reasonable sized medium loads, oh yeah, sure thing. Back in half an hour. I guess in half an hour I have to drop off, but thank you for hanging out with me. It's a pleasure. I will be back next week for sure. So exactly. SQLite has the big advantage. It just creates a file. It runs inside your application. You do not need any setup. You don't need any license. It's for free. And for reasonable sized workloads, it's really, really good enough. So for example, I have my own blog, which, it could run on SQLite. I tried it out. It works perfectly. If you don't have like millions of requests per day, it doesn't matter. The engines are good enough. And especially for those smaller things here, a file database is absolutely, absolutely good enough. An entity framework works pretty simple. So I will show you the usage before I show you how to configure it. Let's go to my controller. That's the expense controller. And here you would just get your DB context. So you have your DB context. You can see here, Microsoft Entity Framework, context. And then you would do something with set context. Here, context. And then I will show you later how all of this works because it's really fancy and cool. Let's remove this for now. The configuration is, I wouldn't say it's tedious, but you have to do a few things. Let's start. Let's create a new folder called infrastructure. And we need one thing. We need our own DB context. Let's call this expense DB context. So we need something which represents our state of a database. It has to implement this DB context here. And basically, we need two things. We need first this one, model creating. I will show you in a second what that does. And we need a constructor. And this constructor is DB context options of options base of options. So that's a lot of code. Okay. Let's put this here. What do these things do? DB context, as showed earlier, is responsible that we can use that stuff later. And the DB context options is basically a placeholder where we can configure stuff like a connection string. I mean, at some point I have to tell, hey, dear entity framework, please use that database, or please use, this and that. And inside this DB context options, that's where it happens. That's the magic. And there's a second thing we have to do. This is this on model creating. Entity framework, what it does is you give him a representation in C#. That would be our expense object. And what we want is that entity framework does all the SQL stuff for us. Entity framework should automatically do the select query. Entity framework should automatically add things to our database, save them, update them, so that we just write C# code. Now, that doesn't necessarily mean you should avoid SQL. Absolutely not. It is vital if you work with databases to understand what they are doing. And mainly also because you for sure will come into a scenario where you have to understand why a certain query or a certain thing is way too slow. And this can happen. Entity framework is obviously not perfect, you just write normally things in LINQ, and then Entity Framework takes your LINQ query and translates that to SQL. And that can go good, but the result can also be very bad. So you obviously should understand to some extent SQL or whatever is your underlying database technology. That is almost vital. What we can do here is we can say, you can see here, he already does that for me. We can configure our object. We can tell Entity Framework our expense object has an ID, so the primary key. We can also tell Entity Framework, hey, let's do this for a second. Dear Entity Framework, our expense. Now we have a property called name. Name. And that name is a required. So in the database, it shouldn't be null. It should be always something. And we can also say, hey, that thing has a max length of, I don't know, 2048 characters. So we have a very fine-grained control over the things it will create for us. There are two ways how a database is created. You can either create them manually and just do the mapping. That's called like DB first. So the database was first, and you just do all the configuration to the current state of your database. Or that's the other way, is you make like entity or code first, where the code is the single source of truth how your database has to look like. In very, very simple development scenarios, you can do something like database ensure created. That thing does nothing else than take your configuration, look how your object looks like, and create all the necessary, insert into create table. With all your constraints you have here, he creates that thing for you. And we will use that for now. So because I don't want to create a table manually by hand, I don't want to introduce something like EF migrations right now, because Entity Framework is just a tool. Obviously, you can write APIs without Entity Framework. You can use other technologies. You can even write it just to a file. You can use key value stores, whatever you want. That's just an implementation detail. That's why I don't want to go too much into detail of Entity Framework. Okay, that is, by the way, a good start. We have our Entity Framework thingy set up, so expense DB context, so we can use that. What we do now is we go to the controller, and now we use our expense DB context. And instead of going, or instead of returning a hard list, what we will do now is basically telling, hey, dear Entity Framework, let's remove all of that. Dear Entity Framework context, I want to have all of my expenses and want to return all of my expenses to the user. But there is no expense right now. Or how do we do that? Let's go again here. There's a very sophisticated way of doing this, and that's called dbset. And dbset reflects one table in your database. So if you go here, I want to have an expenses. Now I have access to all of my expenses. Let's go back, put in the expenses here, and I can just say to list, or the better way in web applications is to use the async version. So I can say here to list async, make that lambda also asynchronous, and I am done. What is missing here? There was one more missing. I'm sorry. Exactly. Cool. This would really retrieve all of our expenses from our database. That's all. Obviously, what you can do, and this is why I said like Entity Framework is a bit magic. You can also say, hey, I have a where clause where I can say, give me only expenses which the expense date is in the past. It should be now or in the past. This is from type. This is date only. Yeah, obviously. Then I'm lazy. New date only. Doesn't it? Oh, then this one to date only. Does it exist? Oh, okay. I thought it exists. Date only. Parse exact. Oh, I thought I can parse it from a given date time. Maybe that works. Maybe I forgot. Date only to string convert. Yeah, why not? I'm sorry, that's my idea. That would be 2024. The month would be 7. So basically, I only want to have stuff which is really in the past and nothing which is in the future. I don't have to do that, obviously, but just that you get the hang of it. Why people like Entity Framework, because this is then, select expenses, or select star from expenses where expense date equals, Entity Framework Core will translate all of this for you. But we don't want this right now. What we want is we want always everything, no exception. Okay. One thing which is missing right now is we didn't put that thing into the container. So this is something we saw earlier with the sample service. We obviously also have to do this for Entity Framework. An Entity Framework has a nice overload. It's called add DB context. This is this friend here. And the add DB context wants to have a DB context. And this would be your custom DB context you have created. In my case, that's the expense DB context. And here you can configure that. So this thingy here is the options. Options, build, and then you can just set everything up the way you want. And I want use SQLite exactly. Data source expenses DBO. Yeah, that seems very reasonable. So if I run that program now, let's go. You will see the first time I access that expense DB context, it will make sure that the database is created, which means it will make sure that there is a thing called expenses DB. And so let's do that for now. We have our Swagger. I don't want to use this. I want to use the get endpoint, which retrieves me everything right now. I'll try it out. Execute. And as you can see, we get nothing back. But this is correct. We get nothing back because our database is completely empty. There's nothing inside. But you can see also here, that is the request we did to the database. And here is my database. So Entity Framework did all of that for me, and I only had to, in a declarative way, tell them how my objects, behave or how they should look like. What constraints do they have? What names do they have? The rest, Entity Framework tries to figure out for you. That's the magic. Cool. That said, with Entity Framework now, we can basically implement all of our controllers in almost no time. We implemented the get. Well, there's nothing coming back. But that's fair. It's fair because we never stored something inside. Let's do that. Okay. We go here to this one, the create case. How would it look like? First, let's make async. I will come in a second again why async is so important. We retrieve the expense as a body parameter. And the only thing we want to do is we want to put that thing into our database. So we have our context. Oops, I didn't get it. My fault. DB context. No, context. I don't want to rename stuff. And now I can say expenses, add that thing to that collection. So I can now say, hey, add my expense object, and I'm good. Well, there's a small caveat with Entity Framework, which is a good caveat. You explicitly have to say, hey, please really persist my changes. Now you could argue why. Why should you do this? This is super stupid. Every time, why shouldn't it automatically save my expenses if I call that async? And the reason is pretty simple. Imagine you have multiple objects here. Like that's obviously very stupid that I add the same expense multiple times. But just bear with me for a second. Imagine it would be like that. Then, what you want is that either all of them are stored or none of them are stored. But you don't want to be in a state where you say, hey, only store one or only store two, and because the third one throws an exception, don't store that. So with these save changes async, you can be sure you can generate atomicity. So you know exactly you add X elements and you press save changes async, then either everything is stored until now or nothing is stored until now. So you don't go into weird invariant states of yours which shouldn't be valid. For now, we only want to have one element and we want to save that. I think why I'm using async and why async is a very good idea in web APIs. So how does it normally look like if you make a request? If you make a request, do I have something like, let me open something like that. I need a tool, exactly. So you are my dear user. Well, you are so, you type something in your browser. That is your browser or your PC. And here is the server. That should be the server. Boop, and then somewhere you have a database. So you make a request. For example, give me all of my expenses. Get all. I'm not good at writing with a mouse. I hope you get the idea. I want to get all of my expenses from that server. A server says, hey, cool, I can do that. You make a request, and what ASP.NET does is it spawns a thread. So you have a new thread, you can almost imagine it like a operating system thread. So this does this, that creates that thing, and then your thread basically executes your logic. That would be this part, for example, or this part, for example. And then what it does is it says, hey, dear database, give me all of your expenses. And your database does something, and your thread is happily waiting. Is happily waiting half a second, or if you have a lot of expenses, it's also happily waiting 10 seconds. And then it goes back, and then it goes back to you. Okay, and that thread is gone. So that thread lived around 10 seconds if your database needed 10 seconds. That's cool, but it's not cool in terms of resource utilization, because here at this point, let's make this red. At this point, he just waited, and he waited 10 seconds. In those 10 seconds, your thread could also just, answer other requests. And this is exactly what you will do with async await. You basically tell every time when your database, this is this part here, when your database is retrieving your elements from its storage, you tell .NET, hey, it's fine if that thing does something else right now. So you're basically releasing your thread that is waiting, and you can just say, hey, do whatever you want, take another request. And once your database is ready, some other thread, or maybe the same one, it really doesn't matter, picks it up and continues your logic. So the cool thing is that because you're utilizing resources the best way possible, you increase the scalability of your application. The worst case I can show you is, imagine you only have one thread available at a time. Obviously, I hope not your server is that in dimension and you have a bit more power, but it would wait 10 seconds here. And if there's another request coming from another user, let's make that green. Like, here's another PC from another user, and he makes a request of get all. Well, oh, hello, you're back. Yeah, exactly. So another, let me hook you up. We were just talking about async await, just that you know why I'm drawing that awful pictures here. The other request is coming in, but because your single-handed thread is still waiting for the database, no one is able to pick up that request and do something with it. So your user here is also waiting 10 seconds until that thing is coming back. And then that thread can be used to make another database call. And with async await, it wouldn't wait 10 seconds here. It would go directly back. It would directly take another request from the other user and does that and process that request. That's why in the majority of cases, and I'm not saying all of the cases, but in the majority of cases, async await is a very, very good idea, especially if you have IO bound operations. And IO bound means your program is out of the equation. Your database is, it's a file or an SQL server somewhere on the internet. or you make an HTTP request to another server. This time where you basically idle around, this time can be utilized way better. And that's what async await does. Okay. A lot of talky for 2 words. I do know. Okay. We were here exactly. So we created the capability of retrieving elements. We created the capability of inserting elements, and that is something. I guess this is something we can already do, and play around a bit. Where we are here, let's use my Swagger UI. I don't want to use Swagger now. I want to use my front end, and I hope it's still running. Was it this? No, it's not 5.1. Ah, yeah, this one. Ah, look at this. My front end doesn't complain anymore. My front end is happily, let's do this again, happily asking the backend. This is this call here. It asks basically, hey, give me all expenses, like we saw very much in the beginning. And what is coming back is basically an empty array. That makes sense because we didn't save anything. So let me remove this one. I hope it's big enough. I have absolutely no idea how I can increase the size of the developer console. Is there a way? More tools. If someone has an idea, I would be more than happy to increase the size of that window. Anyhow, what we're doing now is we want to add an entry. So the expense name is test. It has a value of 10. It has some category. I press OK. And I'm a dumbass. I'm a real dumbass. As you can see, I called the API endpoint expenses, not a singular. So I made the plural form. That was not smart of me. So to fix that, I press one button, expenses. Also expenses because I guess I made that wrong everywhere. So that's a small to do for myself. I have to fix this until the next time, also in the repository. Because it doesn't make sense. Well, you could argue either or, but consistency should be key. Anyway, so now that we fixed it, we basically have an endpoint which is listening on API expenses, a plural form. Let's go back to the, or that's the wrong one. I have too many windows open. Yeah, this one. Awesome. Let's go to add entry. Control mouse wheel. It doesn't work on Mac. I do not know. Wait. Shift, control. I press a lot of buttons. I have like, yeah, mouse wheel doesn't work on Mac OS, unfortunately. I would love to. Anyway, test 10, 100, also 100. Very good category. Okay. And as you can see, something is there, which is good, which is very good. So we sent this thing. Here's the payload. This is what we did send from the front end to the back end. This is what our server basically received, this request. And now, if I just refresh my page, you can see that thing is there. Nice. If I go here to expenses and go to preview, you can see this element is coming back. Awesome. So basically, we found a way of creating an element and getting all of the elements back from the backend. So this is, 80% there. The rest is pretty straightforward. The delete is also very easy. Let's do the delete. We would say, hey, we want to say, here's async again, sorry. And we want to have our DB context again. Expense DB context, DB, I just call it context. Let's stick with one notion. And there we have the expenses, and we want to remove a certain entry. To remove a certain entry, we have to retrieve it from the database first. Oh, he does that automatically. Oh, I love it. And then we want to remove that entry. So we're not done here completely. We want to save changes because also, as shown earlier with the add, also removing, you have to call save changes async. So also I somewhere read that we can tell do not track or something like that. It will increase performance. Do you know how to configure that? Yes, I will show in a second how this is done. Yes, I do know. So here, you can see my editor, it has a squiggly line because maybe expense is not even there. So what if the user tries to delete an entry which doesn't exist? Well, we could just say, okay, that's fine. If this thing is null, we don't have to do anything. We are basically done, and we can say, what do we say? Is like result not found, but we could also say, yeah, no content, because there was nothing. And here, I don't know, we can say results not found. Yeah, we can also say not found. But not found would be an error code, huh? Exactly. Let's do the same. There's still no content because we don't return anything. But here we can shortcut. There's, if we know that thing is not there, there's nothing to delete. So, and I would also argue, why throwing an exception? That doesn't make sense. It's fine. The operation wouldn't look different if there's nothing there, or if there's something in deleted. So the outcome for the user would absolutely the same. So therefore, I would lean towards not throwing an exception in this case. Okay, let's go back here to answer your question with the performance. That is now very, very specific to entity framework. No tracking as no tracking. That's the one you meant. So what Spiritual Mind is asking, I just put it up on the screen once again, is there's a performance overhead with basically tracking. What does tracking mean? Entity Framework has the capability of knowing whether or not your entities will change. So let me make a very artificial example here. Artificial example here. Let's say you have written. Okay, let's put this away. Let's say we have an expense from the database, which would be a context. Yeah, it doesn't matter. It doesn't matter. And we know this is a thing. And now you say, hey, we change the name to updated. Which I can't because this is a private set. Let's remove this for the time being. Let's say we can update that in some way or another. The cool thing is, Entity Framework would know right now that something has changed. And if we do basically save changes async, it would make an update of expense from DB name. But if I use, for example, a second one, and I would not change the second one, then obviously there's also no update happening for the second element. So that change detection of Entity Framework is useful for you because it's a performance optimization to save down or store the changes you made. Entity Framework does that automatically for you. The way it does that is it creates basically a derived class from your class and checks every setter property. So every time you call a set of your properties, it knows that this property has to be stored. And this comes with a cost. And you have to create that proxy somehow. You have to create this wrapper. You have to create that logic, and that logic has to run during runtime. And it comes with a cost. And let's have a look at this code. This code does nothing else than just returning all the elements to the user. The user will never ever mutate that element in the request. Again, we have to be very specific. This context with all its objects is only valid for one request. Creating or loading the page and calling delete are two different requests. So we are sure that in one request, expenses will never ever change. And as we know it will never ever change, there is no reason to pay that cost for this change detection. So what we can do is basically we can tell Entity Framework, hey, don't track my stuff. That makes no sense. There is nothing to track. Yeah, that's all. That's how you do it, as no tracking. You can also configure this globally if you want, but I do think it's best to have it as close as possible to the call. Good. We are almost done. there's not much left. That's good because we are almost out of time, or I'm almost out of time. We did the delete case. Let's start the delete case. Because I was doing it something returning the records. But the table has thousands of records. Yeah, exactly. I mean, if you have really thousands of entries, that becomes noticeable. We are talking then really microseconds. It really always depends on your use case, whether or not you want this. But I'm also leaning towards just having as node tracking, if I know it's a read-only operation. Perfect. So if we go back to the application, it has to be here. What works, we saw that earlier, is we can, retrieve all elements, we can add an entry, and now we can also delete an element as it's gone. Hooray. So we're almost done. The last thing is missing is update. Update. So let's create this again, and it's there. Okay. Update is also pretty straightforward. It's this put here. So what we are doing right now is a bit like what we did earlier with the delete. We want to get this thing. I need the obviously I need the expense context. I want to make it async because I don't want to use too much idle time here. So now I have my expense from DB, and I have basically the expense from the front end, and from the front end is basically the new truth. So what we have to do is the following. We have this one from the DB, and basically we have to update that state and store it down again. And yeah, let's do that. Let's take a find, or we can also use first or default. There are multiple things, by the way, you can use. First or default has the advantage that you can use any predicate you want. Find always uses the primary key, always. Okay. Now here I want to say, hey, if that thing is null, then we can also say it's not found. Get a 4.4 as a result code back. I think that's a fair assumption to do. And what we also want is now, if that thing is there, so if the object is there, we want to say, hey, save changes async. Here is, by the way, where the change detection comes, or where the change detection kicks in. And we want to return results okay, because we know everything was nice and dandy. And now if we execute that code, it'll succeeded. Awesome. We go back here and let me refresh the expense page. Exactly. And now we say la 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 and press here OK. Then you see there's our call. If I go here, that's the put call. We see la 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 la. I refresh the page and it doesn't work. What did I do? Let me think for a second. Of course it didn't work. Well, I never, ever, 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 ever updated that object. So I got it from the database. I checked if this thing is there, and then I didn't do any change and saved nothing down the line. That was very smart of me. What we obviously want to do is exactly that. We want to say, hey, expense from DB, update yourself. That's the domain event or the domain method I defined earlier from the expense object. This is this here. It basically just copy pastes all the properties one by one. I did this because I made earlier everything was private. So now that should work. Let's go back. Let's refresh the page. And let's go here. Let's call it test and 1, 2, 3. Let's press OK. And let's refresh and hope that Stephen didn't. Yeah, exactly. Stephen didn't do a clusterfuck here. Awesome. Well, that's a good wrap up. I guess we could implement all the, let's say, CRUD, so create, read, update, and delete operations with ASP.NET. We saw how easy it is to do that. I mean, if we look at the code, I zoom a bit out. There's not so much going on. Yes, we have a controller, but these controllers are very, very thin. They just get stuff from the database. And to be honest, with such an approach, you can go far. Just by creating, reading, updating, and deleting some entries, you can go really, really, really far. You can build amazing applications without any problem. There's certain things which are not working right now. So the Signal R stack isn't working. That's something we have to do the next session. There's also, just imagine you have thousands of expenses. You don't want to show thousands of expenses to the user. That's not great user experience. And it's also not great for your backend and database, because it has to retrieve maybe really a lot of entries, but you only want to show them 10. We also didn't implement anything in regards of, for example, I just want to have a specific category and stuff. But we can do this the next time. Folks, I hope you had a good time. Again, I will show you the repository last time, which you can use. I just bring it up for myself. This is the Net8 AP Web API workshop. You can check this out, and you can basically rebuild everything from scratch as far as you want. And we are pretty far. We did all those steps. We did a backend. We have an SQLite database. We have post, put, delete, and get. I guess that's get. You can argue stuff here. And we cleaned up the mess. We did this quite early in my GitHub project. I guess I did it a bit differently. But yeah, the next session, that's a good question. Right now, I guess I will just set it live once I fix the date. Very, very, very likely it will be next Thursday. That is at least my current understanding of my own time schedule. It will be roughly the same time if it fits for folks. So 1 o'clock Central European summertime, or don't lie, it should be 11 o'clock UTC if I'm not wrong. Think so. Yeah. If you have ideas, we can also go left and right, completely different things. But I guess handling the session with these topics, Signal are logging, middleware, and exception handler, and especially Web Application Factory. We will be busy quite some time. I also hope that I can fix the issue with my camera. I know that my picture is very laggy. I'm not sure if this is just in my preview video or I'm really laggy. No clue. So yeah, let's see. You're from India. Okay, yeah, this is a bit of a. I shouldn't make it too late, otherwise that will be in the middle of the night for you. Yeah, so that's my current understanding. 1 o'clock. I will set it up on YouTube, and yeah, the recording is also live now. If you missed the start, perfect. I wish you a great day, folks. Bye bye.